Hi everyone, welcome to G5 Israel's first webinar. We are doing an investor briefing and we are extremely excited to have you here with us. My name is Nir Goldstein, I am the Managing Director here at G5 Israel. Thank you first of all for joining us at this very challenging time. I hope that you and your families are safe and healthy. We will begin with a few technical issues. First, please, you can see here at the bottom, we have a Q&A button. If you have any questions, please feel free to drop them there. We will refer to them at the end of David's presentation. We are also going to use this webinar, it's recording. So if you would like to view it later on, we will send it to you. This is today's agenda. We have a very brief presentation of the introduction. Later on, David will take us through the investor briefing. We will have a Q&A and discuss resources. So about G5, globally, our mission is to promote and harness the power of food innovation and markets in order to accelerate plant-based and cultivated meat, eggs, and dairy. All of them also including fish and other forms of animal-derived foods. And we are doing all of it as a non-profit in order to promote a more sustainable, healthy, and just food system. And we believe alternative proteins really have a lot to do in making our world a better place. We are doing it in three main work streams. The first is science and technology. We are working with scientists all around the globe, really, supporting them with scientific advice. We are funding research in universities around the world. This week, we'll announce an investment of about $4 million in open access research around the globe, adding to the funding that we've given in 2019. We are also working in corporate engagement with investors like yourself, but also with entrepreneurs and with big food, agri, pharma companies all around the globe, really trying to harness the great power of the for-profit sector in order to bring the alternative protein revolution to life. And last but not least, we are working in policy with governments all around the globe, both in order to promote funding, governmental funding for this field, and also to promote the go-to-market of this product through regulation and labeling, lobbying. We are working all around the globe. We are based mainly in the US with about 70% of our staff, but we are working nowadays also in South America, based in Brazil. In Europe, we have locations in London and Brussels nowadays. In Asia, we're working in mainland China, in Hong Kong, and in India. And also here in Israel in order to bring Israel innovation to support this global effort. As you can see here at the bottom, we have a seal of transparency, which means G5 is a rather successful nonprofit. We really try to be very professional at the things we do. And now it's my honor to introduce you to Shmuel Rausnitz from SNC, our partners at this event and many others. Hi, Shmuel.
I think I'm unmuted. Great. Hi, everyone. My name is Shmuel Rausnitz, and as Nir mentioned, I am the agri-food tech analyst at Startup Nation Central. It's a privilege to be partnering with GFI for this event. I just want to, excuse me, to say a brief word about SNC, and then pass this all over to our guest. So Startup Nation Central is a nonprofit, completely non-revenue organization. We are non-governmental. We live in Tel Aviv and Jerusalem, and we're about 80 people. We've been around for a few years now. And what we do is we promote Israeli innovation across all tech sectors throughout the world. We work with partners like GFI, governments, major multinational corporations that are leaders in their industries. And again, our overarching mission is to connect Israeli innovators with business partners throughout the world, bring the innovation that they're doing in Israel abroad. We do this in a variety of ways, and I'll just touch on a couple of them that are probably the most important to point out. One of them is our Finder search platform. So this is an online search platform that we built. It's completely free to access, where you can discover all of the companies that are focusing on whatever interest in technology that you have. Can go to the next slide, Nir. Give you an example of what the platform can give us. we can take data from the platform to identify what kind of trends are going on in Israel. So here you can see, for example, investment trends in the alternative protein space in Israel. And that the companies have been bringing in more and more money, more and more investments, justifying GFI's presence in Israel for sure, and bringing greater value throughout the world in innovation in this space. Aside from that, we work with our corporate partners to bring them to Israel and meet with startups that we think could be great partners for them for business, among other things, but that's all I'll say for now. So I hope you enjoy the rest of the webinar. Nir, back to you.
Thank you, Shmuel. So now it's my pleasure to introduce you to David Welch, our Director of Science and Technology. David has a PhD in plant developmental cell biology. He has really vast experience in the life science industry, where he held various positions in both business development, marketing, product management, and more. He joined GFI, lucky for us, in 2017. And now as GFI's Director of Science and Technology, he oversees a really wonderful team of scientists all around the world. David, thank you so much for joining us.
Thank you, Nir, and hi, everyone. Yeah, I'm just going to share my slides and then. All right, it's really nice to be here today and to talk to you about some of the emerging opportunities we're seeing in the alternative protein sector. As Nir mentioned, I'm the Director of Science and Technology at GFI, and one of our primary goals is to identify the most important white spaces to help this industry accelerate forward as fast as possible, and then use those white spaces to inform organizations, companies, investors like yourselves to direct the type of research that we fund, to build case studies, and ultimately to help research centers form around the world to tackle these large white space ideas that are so important for the industry. And one of the primary questions that drives our thinking around these white spaces is how will we feed the 9.7 billion people that are projected to live on this planet by the year 2050 in a way that's sustainable, efficient, and safe, and importantly for the investors and companies that we support, a way that's profitable as well. And our existing food system, particularly the use of intensive farming, presents some significant investment risks that can be solved by this new alternative protein industry. For example, many of you will know that factory farming produces a significant amount of greenhouse gas emissions. In fact, it produces more than the entire global transport sector combined. It's also the #1 user of fresh water on the planet. And I think we're all familiar with the deforestation issues associated with intensive farming. But what many people don't know is the use of antibiotics. And factory farming is actually the #1 user of antibiotics globally, which is causing challenges with superbugs and antimicrobial resistance, which projections state that if this is left unchecked, this could cost upwards of $100 trillion by the year 2050. So very significant investment risks in the current food system. And there are also market disrupting events associated with the current intensive farming industry that can have an enormous financial impact as well. A good example of this is swine flu, which has really hit the China's pig industry in the last couple of years. There were hundreds of outbreaks since the middle of 2018, which resulted in half of Chinese breeding pigs being either killed or dying because of the disease, costing significant amount of money. And you can see in the graph here the reduction in the number of available pigs and the rapid increase in the price of pigs and pork. And also, ESG risks are fairly significant in the current industry. A good example of this is the 2018 drought that affected South Africa, which resulted in the culling of almost a quarter of that country's sheep population, costing roughly $1 billion US. And there are other challenges this sector is facing, from waste streams and how to dispose of those correctly, to deforestation challenges, all of which leaves this sector ripe for disruption. And we're seeing significant growth in the plant-based meat industry, 23% or above, and significant investments, as we heard before, not just in Israel, but around the world. Over $17 billion of investments last year, and a rapid growth in the number of investments as well, and significant movements like the Beyond Meat's IPO. And I'll add, if you're interested in learning more about some of these environmental risks, I would definitely recommend heading over to fair.org for even more detailed information. So what is the current market size? Well, we've aggregated some of the available market reports, and you can see from this slide that there's a pretty large variance. But if you aggregate these together and look at the projections 10 to 15 years out, the consensus seems to be that plant-based meat will have about a 10% market share of the total meat market. That's both a 10% share in the US, but also globally. UBS being the most conservative, estimating about a 6% market share, and A.T. Kearney, far more bullish, estimating a 23% market share in 2035. But I think you can see from this slide here that from a global perspective, we're looking just in a short period of time of 10 years, a market size of roughly about $100 billion or more, and 10% of the total meat market. And this is being driven not by the vegan and vegetarian consumers of the world, which remains at about 6% of the total population, no matter what country you look at, but really by omnivores and flexitarians that are looking for a more sustainable food source, but still want to eat products that taste like meat, like dairy and egg. And this is really what's driving this market forward. And we're often asked, well, is this just a fad, or is it really a trend that's going to continue? And the data suggests that it is in fact a trend. So this slide here shows you that the number of new product introductions with a vegan claim, global by region. And while this only goes up to 2017, I think you can see that rapid rise in the number of new product introductions. And we're seeing the same trend continue. In fact, in 2018, 14% of global meat launches had a vegan claim, and we're seeing that continue into 2019 and 2020. Another great example of this trend and continuing trend is the rise of plant-based options in US restaurant chains. So you can see the same type of hockey stick effect happening here, where companies like Impossible Foods and Beyond Meat and others are launching more and more products in these big US chains, first at a few locations to test the products, but then launches at all of their restaurants around the country. And we're seeing similar trends in other countries around the world as well. Another really interesting way to look at the potential market size for this plant-based meat sector is to compare it to plant-based milk, which if you were to look, say, 10 years ago or so, it had about the same share as plant-based meat today. This is looking at the US retail market on this slide. So back 10 years ago, plant-based milk was about 1 to 2% market share, and it's grown to now 14% market share. And we're again seeing similar growth trajectories and market share capture around the world. So if we take that 14% market share number for plant-based milk and look at where plant-based meat is today, 2% of the US retail market, and then look at what it would take to grow that to the same market share, 14% of the total meat market, and use $95 billion as the total meat market size, we can calculate that this is a $12 billion opportunity just in retail sales, just in the US. So I think you can see from this that there's examples, data showing that this is a continuing trend upwards in terms of the number of launches. We're seeing increased interest from that large segments of omnivores and flexitarians looking for these types of products. And we have historical examples from plant-based milk where it's continued to capture more and more market share from conventional milk. So with that, that basis of where the market is and where it's going, now I'd like to take you into the alternative protein landscape as we see it. So at GFI, we look at the alternative protein landscape fitting into three categories from a production, cost, and infrastructure perspective. So there's proteins that can be derived from plants. We can use fermentation or microbial fermentation to create ingredients for these products or alternative proteins. And we can use animal cell culture, or also known as cultivated meat or cultured meat, to produce proteins from actual animal cells. And when you look at all three of these, and even the conventional meat production process, they all follow a similar process across all of these categories. We have some type of source material. It might be an animal, it might be a microorganism or a plant. We optimize that in some way through breeding or other technologies. We then need to grow that source material, and that can be done either on a farm or in some kind of tank like a bioreactor. And then ultimately, once we have that final output, we need to process it in a way to turn it into a product that consumers are going to want to eat, that tastes great, and is priced competitively and available everywhere. And while there are these three distinct technology sectors that we look at, ultimately we see a future where these animal products alternatives will occur along the spectrum, where you have on the left fully plant-based products like tofu, and on the right fully cultivated or cellular agriculture-based products like synthetic gelatin and recombinant milk and egg proteins. But in the middle, we'll have these hybrid products that combine ingredients from all of these three technology sectors to create the types of products that consumers are looking for. And an early example of this is actually the Impossible Burger, which is primarily plant-based, but uses a soy-like hemoglobin, which is produced through fermentation technology. So what I'd like to talk through now is how we're doing this with using plants. So this slide here gives you a high-level overview of how plant-based meat production happens. As I explained on that overview slide, we need to start with the source material. So what is the best crop, the best plant to grow for a particular end product application? It could be soy or pea, or it could be a more novel crop that's being used like chickpea or lupin or quinoa. We then need to optimize that crop. And this can be done through traditional breeding methods, or we can use modern gene editing technologies like CRISPR to optimize that particular plant so it provides better nutritional or functional characteristics. Once we've optimized that crop and we're growing it, we then need to extract and optimize the raw materials in it. And we can use both mechanical and chemical or enzymatic methods to isolate key raw materials and then functionalize them so that they behave in the way that we want in that final product. And then the last part is to take that new toolbox of raw materials that have been optimized and combine them together in the right way to create a product that consumers want to eat, that has the right sensory characteristics, the right nutritional profile, and is priced competitively. And one of the primary challenges or primary questions that drives modern plant-based meat research is this question: how do we persuade globular plant proteins that are typically used for storage in plants to act like animal proteins? So how do we change them from a globular structure to a fibrillar cross-linked structure, much like the proteins that we see in meat, such as in the cells in muscle? And currently the industry has really two choices. We can use mechanical methods to do that, and the instrument of choice today is the twin screw extruder, which takes plant proteins and uses high temperature and high pressure to modify those proteins so that they then act more like animal proteins, and you get that textured plant protein that you're very familiar with if you've eaten plant-based meat products. There are also new technologies being explored, such as 3D printing and shear cell technology, which uses rotational forces to modify plant proteins. But we can also use enzymes to change the structure of plant proteins and cross-link them in different ways to create different textures, different hardnesses and softnesses. And this is really a big white space area for the industry to not just rely on traditional extrusion, but to optimize extrusion systems to make them more consistent, more efficient, more sustainable, but also to look at more modern technologies like 3D printing or the use of multiple enzymes to reconfigure these proteins. And we're seeing now a lot of research and a lot of startups looking at different technologies to move this industry forward more quickly. So once we've solved these issues and we can scale up this industry even more rapidly, what kind of infrastructure requirements are we going to need? What type of investment are we looking at to build out this entire industry? Well, there's not a lot of publicly available examples of the cost to build new facilities, but there are two that we can look at. And if we imagine that future state, say in 5 years' time, when we've captured 10% of the meat market, that equates to about 37 million metric tons of plant-based meat. And that's from the AT County report that I mentioned previously. So we look at these examples from the company Corn and the Vegetarian Butcher, and the current volumes that they're producing per year, and the facilities that they are either in the process of building or are about to build. The cost for corn, $34 million to produce just 0.02 million metric tons, and for the Vegetarian Butcher, $8 million to produce 0.007 million metric tons. And if we extrapolate that out to what we're going to need to produce 10% of the meat market in 5 years' time, we're looking at somewhere between $40 to $60 billion worth of investment. That would be greenfield new facilities to meet these volume costs. So you can see that not only are there big opportunities to improve specific technologies in the plant-based meat space, but significant opportunities to help this industry grow, to build new manufacturing facilities and new infrastructure and supply chains. And some of the key white space ideas that we've identified in our recent work with both internal GFI experts and external experts around the world are these ones I've listed here. So a couple of key commercial ones, which I'll talk about in more detail, and then a couple of R&D ones to look at better bioinformatic tools to identify the right proteins to work with, and even to improve the meltability and stretchability of plant-based cheeses. But I'll focus on these two commercial ones in this presentation, and the first of those being end-to-end product development and co-manufacturing facilities. So as I talked about before, one of the challenges this current industry faces is the use of fairly expensive equipment like high moisture extrusion systems. And there's really right now a limiting factor in the availability of these systems, but either to bring them in-house to a new startup or access to co-manufacturing facilities. So we see a really big white space opportunity here for the development of co-manufacturers that can help startups and existing companies with end-to-end product development, from the initial product development of a prototype product all the way through to scaling it up to full manufacturing scale. And then a really big opportunity we see in terms of end products is in plant-based seafood and specifically flaky fish. Currently, plant-based seafood accounts for about less than 1% share of the overall plant-based meat market. So really big opportunities here to for plant-based seafood that biomimics conventional seafood. So plant-based meat is one technology. Let's move on to fermentation, which again follows the same production flow in that we're selecting a source material. In this case, it's going to be some type of microorganism, could be from fungus, a bacteria, or an algae. Again, we're optimizing it in some way, so we're optimizing that strain so that it grows more efficiently and uses the most efficient feedstocks and produces the right types of proteins in the end. We're then fermenting this typically in a large bioreactor. And then in this industry, there's two general types of products that are being produced. Either it's protein biomass, so we're using the entire protein content in the cells, and that's being turned into a product, or we're using recombinant protein technology to produce an individual functional protein, like a recombinant dairy protein or egg protein. And we're seeing a lot of new entrants into this industry. On the left are companies that are using fermentation technology to produce protein biomass. The existing example here is corn, which many of you will be familiar with, that is using producing mycoprotein-based products and has been on the market for quite some time, but we're seeing a lot of new entrants. At the top of this slide on the left, there are companies like Emergy and Atlas Foods that are producing whole cut products. So using fermentation technology to produce steak or bacon like products. And then down at the bottom are companies focused on using the same technology, but to produce ingredients that can be used as part of a final product. And really interesting examples here are companies like Air Protein and Solar Foods that have identified microorganisms that can consume waste streams such as CO2 as fuel. And then on the right, we're seeing a really rapidly growing sector here of companies developing specific functional proteins, such as Perfect Day developing dairy proteins, Geltor producing recombinant gelatin, and then companies such as Motif Foodworks that are more agnostic and using the same technology to produce a wide variety of ingredients. And ultimately, what I think we're going to see is that fermentation is going to be used along this entire spectrum that I mentioned before. So enzymes to improve the functionality of plant proteins, like I mentioned before, flavoring ingredients such as the soy-like hemoglobin in the Impossible Burger, growth factors that can be used for cultivated meat that I'll speak about in just a second, and then 100% fermentation-derived ingredients, such as the ones I spoke about on the previous slide. And the exciting thing about fermentation technology is how rapidly it can disrupt the market. So there's some really nice examples on this slide of when products like rennet, which is used in cheese making process, or non-animal insulin were introduced to the market. You can see that really rapid growth in the percentage adoption. And a lot of this is based on the complexity of the protein that's being developed, the concentration in the final product, and how scarce that product is. But I think what we're likely to see in the coming years as this sector grows very rapidly is that proteins that are fairly simple in nature, that are present in low concentrations, are likely to capture market share very, very quickly. And the big question that's facing this fermentation industry right now, which is very similar to the challenges that have faced and are facing the biofuel industry, is can we get the cost down? And I think this is the answer to this really relates back to that previous slide. Is it really depends on the complexity of the protein. So how much effort and resources do you need to put into engineering the strain and purifying the protein? But more importantly, how much of this protein is required in the final product? If it's just required at a few percentages, then I think it's likely we'll see more and more market entrance into this space, whereas ingredients might be required at 10 or 20% or more. I think it's going to take a while before we see those enter the market. Some interesting white space opportunities here again on the fermentation side. So the first one I'll mention again on the commercial side is not just applying this technology to new proteins, but also looking at lipids and binders that can be added to plant-based products to improve the functionality and the sensory experience of those. Fats is a really hot area right now for this entire industry, and today the industry relies on just a few sources of plant-derived fats, such as those that come from coconut. And there's really a big opportunity here to utilize fermentation technology to produce more functional lipids and fats in a more sustainable and cost-effective way. And then as this industry grows, there's going to be a bigger and bigger need for feedstocks that suit the different strains that are being used. So we see again a really nice white space opportunity here for a marketplace for the various feedstocks that are available to ferment these microorganisms, and even to use waste streams from other industries as fuel. So we can create a very efficient circular bioeconomy in this fermentation space. So I've talked about plant-based proteins and fermentation, but many consumers are still going to want to eat actual meat that comes from animals. And this is where cultivated meat production comes in. And while we're not using the animal in the same way, we're taking a small sample of cells from an animal and then using those as the starting point to produce the cells and tissues that make up meat, which is primarily fat, muscle, and connective tissue or fibroblasts. So in this process, we're taking a small sample of those cells from an animal, we're isolating the stem cells that we want to work with, and then we're entering the first phase of this process, proliferation, where we're using the inherent properties of these stem cells, that they divide multiple times to produce a much larger number of these cells. Once we have enough of them, then we're moving to the maturation phase, which most likely will involve a different type of bioreactor and take advantage of scaffolds to provide a three-dimensional environment for these cells to grow. And then at the end, we're producing a piece of meat of different kinds. This process will likely take about 6 to 8 weeks, depending on the product we're creating. So much faster process than growing an animal in the way that we do today to produce meat. This industry has grown extremely fast. So a few years ago, there were just a handful of companies, but now we see more than 50 or 60 companies around the world, not just focused on developing products for consumers, as you see on the right there, but also companies focused on B2B, so developing bioreactors, scaffolds, cell culture media that's specific for this cultivated meat industry. And we're seeing an expansion on the B2C side in terms of the different types of food that are being created, from beef, chicken, pork to even pet food, and a really rapidly growing seafood sector. And also companies that are in the middle there that are agnostic and developing multiple types of food using cultivated meat technology. There's also a lot of hype in this space as well that I'm sure you've seen. And I'll just briefly touch on this slide and talk through what today we see as reality and is still hype. So getting to mass market price in the next couple of years is pretty unlikely at this point. And this being a single solution for climate change, also unlikely. But when we look over on the right, there are some realities to this technology. It won't require antibiotics. It won't require animal serum to culture the cells. Production times, as I mentioned before, are going to come down quite rapidly. And the amount of land we'll use for this process will be significantly reduced compared to conventional animal agriculture. It's likely that we'll be able to match taste. We'll have a diverse number of products. And at the same time, foodborne illness, because of the way these products will be developed inside a clean facility, will come down significantly. And energy use and water use will come down as well. There's still some regulatory questions that remain unanswered in terms of the pathway that these companies will take to launch products in key countries around the world. But we are seeing really promising progressions here. The USDA and FDA have agreed to jointly regulate these products, and we're expecting more guidance from them in the coming months. And a number of countries around the world are making a lot of progress in defining their regulatory guidelines and offering promising pathways to the market. Hong Kong and Singapore and Japan being notable examples of that. And in this cultivated meat space, just like in the other sectors, the main challenges that face the industry today are around cost and scale. And a particular one that I wanted to speak about today is the cost of the cell culture media that's used to grow these cells. Right now, cell culture media makes up somewhere between 60 to 90% of the costs of these cultivated meat companies. And this is from a survey that we did. And if this industry is going to be commercially successful and be able to compete with conventional animal meat, we're going to need to bring the cost of cell culture media down from several $100s a liter to less than $1 a liter. So how do we do this, and what are the opportunities here? Well, if you look at the ingredients in cell culture media, many of them, these boxes in green, are actually available as food grade components rather than pharma grade components, because the majority of commercially available cell culture media products on the market today are really designed for the pharmaceutical industry to develop therapies, and they obviously have different quality requirements. So we can pretty easily take all of the ingredients in these green boxes and move them to food grade versions, thereby lowering the cost. The challenge is really in this orange box. So these growth factors that signal to the cells to remain in a proliferative state or start to differentiate into muscle and fat. This is where the majority of the expense is. But we've done some work at GFI along with some external collaborators to show that it is indeed possible to lower the cost of cell culture media. So by moving components to food grade, but also by reducing their concentration of these growth factors, and this could be by just optimizing the cells and the growth conditions, or by making these growth factors more efficient, so we need less of them in the culture media. We can, as you can see on this graph here, in a stepwise manner, we can bring the cost of the cell culture media down to less than $1 a liter. And this was a paper exercise that we did, but much of this has recently been validated by Paul Burridge's lab here in the US, where he did the same thing, but actually doing experiments on it. So he moved to food grade components, and he engineered some of these growth factors to be more efficient so that the cells needed less of them. And he was able to obtain a 97% cost reduction, so down to about $10 a liter. So still not where we need to get to in terms of $1 a liter, but getting closer and closer. So again, I think this is a big white space opportunity here. We've done some initial demonstrations that we can reduce the cost. And now there's opportunities for new companies to get started, or existing companies to move into the cultivated meat space and start developing commercial grade versions of these inexpensive cell culture media formulations. So once we do that and we solve some of these initial cost and scale challenges, what are we talking about in terms of the scale of this market? So similar to the example I provided you on plant-based meat, we're going to need a lot of capacity. If we look at the current available bioreactor capacity for mammalian cell culture in the pharmaceutical industry, we're sitting at about 16.5 million liters of capacity. In order to meet 10% of the market share in 2030, we're going to need 4 billion liters of capacity for cultivated meat alone. So that's almost 250 times the current global capacity. So some pretty significant, again, growth opportunities here in the infrastructure side. It seems fairly insurmountable, but I think, I think what this presents is interesting opportunities. We can solve these technical problems on a smaller scale, And then we're going to need large manufacturing facilities around the world, supply chain infrastructure as this industry grows and grows over the next 5 to 10 years. And leading on for that, we have some more interesting white space ideas. I won't touch on the research and development ones on the right, but I think just to briefly highlight the growth factors for proliferation. So this goes back to those cost challenges I mentioned before, and we're starting to see some R&D focused on re-engineering these growth factors so that they are more efficient and we can use less of them in the final media formulation. So some really big white space opportunities there, either on the academic research and development side or in new companies that are getting started to produce growth factors specifically for the cultivated meat industry. But on the commercial side, for those of you familiar with the cell therapy industry, there's a pretty large segment of this industry now that exists to supply cells to the remainder of the industry so that they can identify the best source material for cells, isolate the stem cells that are going to be worked with, and then bank them in a robust environment and create a distribution network so that companies and researchers around the world can access these cells. We at GFI recently entered into a partnership with a US-based distribution and cell banking company called Carafast, which will begin to hold and bank and distribute cultivated meat cells for the industry. But there's much more opportunities here, even in Israel alone, where there's, as I'm sure you know, there's rapid growth in the number of cultivated meat companies, and they're maturing quickly. I think there's some really interesting opportunities here to create cell banks that can provide these cells to the industry around the world. And then again, using the cell therapy and pharmaceutical industries as an analogy, there are a lot of CMOs that exist that can help young startups optimize their growth conditions and scale up without having to make significant capital investments early on in their growth. And again, here in the cultivated meat space, we see some really important white space opportunities to create CMOs and joint ventures that can service this rapidly growing cultivated meat industry. So I've spoken to you today about these three technology sectors that utilize different technologies, but ultimately are being used to create ingredients that in the future, as I mentioned before, will be used along a spectrum from fully plant-based ingredients or products on the left to fully cultivated or synthetic ingredients on the right. And this future state where product developers at food companies are not just making 100% plant-based products, but they're really selecting ingredients from this rapidly growing toolbox of ingredients from fermentation technology from plants and from cultivated meat technology to assemble a product that has the right sensory characteristics that the consumers are looking for, that is priced competitively and can be manufactured wherever it needs to be manufactured. And I'll end with a slide to leave you with a thought on how this industry is likely to look in the future relative to the conventional animal industry, which does an amazing job of valorizing every part of the animal to bring profits in an efficient manner. And I think in the future we'll see a feed industry of the future in this alternative protein space as well, where we're using every part of the plant or the microbe or all of the side stream biomasses to fuel the entire industry. And to give you a few examples of this, so these high molecular weight proteins that are being extracted from plants or through fermentation processes can be used for these texturized inputs into plant-based meat, egg, and dairy products. But we can also use the amino acids and small peptides as inputs to the cultivated meat industry to lower the cost of that cell culture media. And even simple sugars and some polysaccharides and starches can be used as fuel for microbial fermentation processes or to create scaffolds for cultivated meat. So just to summarize, a really big market projected to reach somewhere between 100 to 370 billion by 2035. Innovation occurring across all three categories of alternative proteins. A lot of opportunities for supply chain, infrastructure improvements and scale up. And this is going to create not only massive opportunities in the food industry, but it's going to translate back to the life science industry, even impacting the pharma industry, and creating big opportunities for incumbent ingredient suppliers and fermentation. If you're looking to learn more, as Nia mentioned before, we have a lot of resources, much more detailed analyses of the market and the science behind this. And we can even run workshops for companies and for investors like yourselves, and even information on policy briefings and making industry connections. And if you are interested in more, I'd suggest that you head on over to our resources page at gfi.org, where you can find all of the much more detailed information on everything I spoke about today. So I'll end there and open up the discussion for questions.
Thank you so much, David. We do have time to take a few questions. If any of you would like to add questions, please put them at the Q&A section. Let's see what we've gotten already. So the first question is obviously about the hottest topic nowadays, coronavirus. How do you see this affects alternative protein in the industry?
Yeah, I mean, I think short term, all industries are being affected by this, and it's hard to say how long this will go on for. Longer term, I think, I hope that this will push consumers to think more globally about some of their food choices and how those choices might impact issues like foodborne diseases and antimicrobial resistance. As I spoke about in the beginning, there's a lot of global health implications tied to the way that we currently use food, and I'm hopeful that this will result in some positive moves in our food system. I see a question on price. What is your best estimate on where we are on price now? I think this is a great question. I think that in all of these three categories I mentioned, well, cultivated meat, there are no products yet, and so those are still very expensive. But in the plant-based sector, prices are starting to come down. We're seeing examples of products that are getting closer and closer to the conventional animal counterparts. So I think when you look at some of the ingredients that are being used, it's really only a matter of time before the price of these ingredients comes down as scale goes up and there's an increased demand. And also these plant-based meat companies become more efficient at producing these products. So we're seeing movement in the right direction, and we're quite confident that the prices will continue to drop.
We have another question about innovations in scaffolding and blood serum. Maybe you want to refer to that as well?
Yeah, there is some interesting work happening in scaffolds, particularly using edible materials such as those derived from algae and seaweed and plants as scaffolds. I think the industry feels right now that this is likely to be the most efficient route to market for scaffolds. If you can choose an ingredient for your scaffold that is already approved for food consumption, rather than trying to use some novel material that then requires additional regulatory approval. In terms of removing blood serum, this relates back to the growth factors that I spoke about before. So there are already a number of commercially available synthetic cell culture media formulations on the market, but which remove the need for serum. in media, but these, as I mentioned before, were designed for the pharmaceutical industry. So from a technical perspective, we already know how to remove serum from the cell culture process, and it's been done for over a decade. The key now is to figure out how to reduce the cost so that it works for cultivated meat, down to that less than $1 a liter that I mentioned in the presentation. But we don't see any major barriers. It's more just companies and researchers doing the work and then scaling up these food grade formulations. I see a question about being interested in alternative proteins, not being an expert in the field, who can perform due diligence for such companies. So we actually have a list of external experts that we've spoken to that are knowledgeable in all three of these technology sectors that I mentioned. So we can provide that list to anyone that's interested, and those people can provide that that due diligence. So you're free to reach out to me. You can see my email on this page, and I can connect you with some of those experts. How can I find companies to invest in this specific area? We have a company database that I think we can share with this group afterwards, which lists many of the companies in this space. We also have a newsletter that goes out every couple of weeks called the Plant-Based Insider, which sometimes profiles interesting companies in this area. I see a question on cultivated meat. What is the estimated pipeline until we see a product in the market? Yeah, this is, as you can imagine, I get this question quite a lot. Generally, what we see is that the initial path to market is likely to be a very small scale launch at a high-end restaurant. So just more of a sort of taste testing for a final product. And we expect that to happen in the next couple of years. Likely, everything points to that happening in Asia, which is, you know, at the moment fairly favorable to those types of launches. So that's obviously going to be expensive and not designed for the mass market. I think, you know, when in my presentation, I spoke about some of these scale and cost challenges, particularly around cell culture media, but there's also technical challenges around, say, the right scaffolds, the right bioreactors, and then scaling all of that up. I think we're looking at, you know, 10 to 15 years time before we see products that are at price parity with conventional meat and available for the mass market. All right, next question. What are the different approaches, competitive differentiators, the new blood, serum, and scaffolding startups are taking? Yeah, I spoke about this a little bit already, but in terms of scaffolds, I think there's different types of technologies that can be used, different ways of constructing these scaffolds or spinning the fibers together. So there's numerous technologies that are being looked at. But I think the key, as I mentioned before, is about the material that's used and trying to identify materials that are already approved for food consumption. And then on the recombinant growth factor side, yeah, I think I talked to this already, but here it's really about identifying ways to make these growth factors more efficient, so that we need less of them in the final product, even if potentially attaching growth factors to scaffolds rather than having them in the media, which could again lower the cost.
Obviously, people are asking about how Israel compares to other hubs in the world. How do you see it?
Well, I think on the cultivated meat side, I think Israel is one of the pioneers. We have some really exciting companies in Israel, and I think arguably Israel is further ahead than any other country based on its size and the number of cultivated meat companies it has than anywhere else. So I'm really excited about what's to come in Israel, and we're starting to see a lot more growth in the other two technology sectors as well. on the plant-based side and fermentation. In fact, we have a seminar later. I think it's next week, right, Nir, on fermentation, and we've seen a huge amount of interest, which I think just shows you the promise in Israel for in these other technology sectors as well.
I share your excitement about Israel for sure. Where do you see regulatory challenges regarding fermentation?
Yeah, I think so. Fermentation is already a widely used technology in the food industry. So, you know, I mentioned in my presentation the use of rennet, which is a fermentation-derived ingredient that's used in the cheese-making process. There are many enzymes that are used in food production. So, regulatory bodies are comfortable and familiar with approving fermentation-derived ingredients for the food system. So I think that's a big positive. I think it's really going to depend on the type of ingredient that's being created. If it's analogous to something that already exists in the food industry, such as a dairy protein, if you're producing exactly the same protein that comes from a cow, but doing it recombinantly, then the pathway seems like it will be relatively straightforward. Whereas if you're creating something that's completely novel, that's never been consumed before, then the pathway is likely to be more complicated.
There's an interesting question about the surge in capital and valuation of companies, which is, you know, we're living in times that are is a bit challenging. But do you think there is some overinflation in our field by now?
I think there's a lot of excitement. It's hard to say. I mean, I think there's been, you could argue that there's been inflation or hype in a lot of technology sectors, not just the food space, but you know, in traditional technology areas, and even in some of the other areas I touched on, like cell therapy. So I think it's kind of just following these other high tech sectors, but it's unclear right now whether there's going to be a rebound effect.
Okay, last question for today. Do you think that by 2035 people will still want to eat alternative protein, or are we all going to just take pills?
Yeah, that's a great question. I think based on how long people have liked to eat food and not just swallow pills, I think it's highly unlikely that by 2035 we're going to be, you know, everyone's going to be drinking Soylent or just eating pills. People, every survey that's done, all the interviews that are done show that people really like to eat meat. There's a lot of cultural aspects tied up in the consumption of food. So everything we see suggests that people will want to keep eating food, particularly meat, egg, and dairy products, but they'll want to do it in a way that is more socially conscious, with more respect for the environment and for our planet. So I'm very bullish on these technologies being necessary in 2035.
Okay, thank you, David. Just wrapping up with introducing G5 Israel team. We have the amazing O. Benjamin as our Director of Operations, the wonderful Dr. Tom Ben-Arieh as our Senior Scientist, the marvelous Hadass Karshai as our Marketing Manager, and I'm running out of titles, but Lior Schneidman, our great Executive Assistant. And we are also hiring. If you want to join us, or you know someone who might want to help us revolutionize the global food system, we're hiring for an academic relations manager to help us find and accelerate innovation in the Israeli academy. we are looking for a business engagement manager to help us talk to you, investors, big food companies, entrepreneurs, and then a policy manager to help us drive a national plan really to promote alternative protein R&D. You can contact us directly at israel@gfi.org or on our Facebook and LinkedIn at the Good Food Institute Israel. We have a bunch of activities planned for you while you're stuck at home. Later on today at 5, we have an event again with Startup Nation Central and the Growing IL Agritech community regarding the Agritech opportunities in alternative protein. David again will be the main presenter. On Thursday, we have an Science of Alternative Protein webinar, which is giving a basic overview of the scientific side of alternative protein. Sunday, we have an event with the Tel Aviv University regarding the business side of things. We will be joined by great speakers, more on this to come. And on Monday at 2, a very interesting event regarding fermentation and cellular agriculture, which David talked about here just a bit, but we are going to get more deeply into the science side of things. I would like to thank again our partner of Startup Nation Central, Shmuel. Thank you so much for helping with bringing this event to the Israeli investor audience. And that's it for now. תודה ובתיאבון.